Okay, now we're going to move on to the initial ISE config. Again, brand new ISE nodes. I deployed them. I did go through the startup script in the background, gave them their IP addresses, host names, DNS servers, that type of stuff, and let the initial install get out of the way. But if we jump into ISE, the primary node, I should say primary admin node, secondary monitoring node as to what it'll be in our environment here. They are at 50.10 and 51.10. So when we log in for the first time, they're going to ask us to provide some information. We're just going to be using the eval licensure, so we don't worry about any of this right now. And the first thing I would typically do is any patches and updates that need to be done. So right now this is ISE 3.2, and I would go ahead and go to administration and down to maintenance and install my patch, which should be available to me out here. We hit install here, do the exact same thing on the other node. And you wouldn't necessarily have to do this in this specific order. You could, of course, build the ISE cluster first and then do the patch update on both of them and so on and so forth. But this is just how I'm doing it here. I'm going to go ahead and pause the video because this patch does take quite a while. You'll notice when doing ISE patches, you choose the file, you hit install, you see this waiting for the IP address, and it kind of sits here and doesn't give you a whole lot of information. Once the patch installs or starts to install and it stops services and whatnot in the background, of course, we get kicked out here. So I'm just going to let this sit for a while, and we'll come back and relog in and make sure that it applied properly on both nodes. Okay, so we're back. Our ISE nodes have booted back up. We should be able to validate that our patch installed properly. In this scenario, I do have two ISE nodes. We could get into a whole conversation about how to size ISE, how many nodes you need for redundancy, performance, scalability. I really wouldn't even need two ISE nodes in this lab, right? I could do the whole thing on one. I just thought I'd have two to show from the switch side that, hey, we have redundancy in the Radius servers via the Radius group. If one of them were to fail, we're still fine. So in here, patch 3 has been installed. We can see that over here. We can also see patch 3 has been installed, so now we need to bring these ISE nodes together. Under the deployment tab, notice there it said it was in standalone. We're going to go ahead and make this guy primary. I'm going to pause the video here because this will take a minute. Okay, that finished. Next, we need to go back to deployment here, and we are going to register a new node. This node will be our second. But before we do that, we'll notice that we can only add this host via a fully qualified domain name. So I'm using, obviously, my internal DNS that lives on the Active Directory server. for this. So I need to go into DNS, and I need to create a couple of A records. And as I do this, the other thing I need to make sure of is that my reverse gets created too. When it there's a checkbox here for create associated pointer record. If the reverse lookup zone for that subnet doesn't exist, obviously it can't create that. Mine here, we've got 50 and 51, and we notice they both came in. If that's not there, when you're working with multiple ISE nodes down the road, when it gets to joining Active Directory domains, etc., you will have some issues. So here, ISE 03. There we go. Came up, said, hey, there's a certificate issue there, which we would expect. It's all internal certs. And at this point, I hit submit, and we will pause again. So here we got this pop-up saying it was registered successfully. Data will be synced. And we can see over here that it is in progress. I'm going to pause again and let this finish. So after a little time here, we can see, came back, both nodes are green. One thing to take a look at, and actually something I forgot to do that I typically do in this scenario, we can see that each node has personas, roles, and services. So when I look at the personas here, we've got administration, monitoring, and policy service. In larger deployments, you could typically have 2 admin monitoring nodes without policy service. You could have a bunch of other nodes that are just policy service. Those are the ones that handle our radius requests, etc. And then in addition to that, when we look at admin and monitoring, we've got primary and secondary. And typically when I do my deployments, I set O1 as the primary admin, secondary monitoring, and then O2 as the secondary admin, which it is, but primary monitoring. So I'm going to go in here and fix this quick. Pretty simple. We're going to switch monitoring to primary and save. And I'll pause the video again because this does take a little time. Now that that's done, then over here to the right, we've got a list of services that these nodes perform. That list comes from the list of services here. For the sake of our lab, we really only need what's there today. We have the session services, we have the profiling service, which we'll use later, not doing anything with threat-centric NAC, SXP. Device admin is your TACAX licensing, if you're going to use the ISE for TACAX. And passive identity services, or PIC, will integrate with Active Directory to pull back identity information. And lastly, PXGrid. Then on the profiling configuration, this is a list of all the ways that ISE can gather profiling data, right? So we can send it copies of DHCP requests. We can set a port that simply listens for DHCP and span DHCP information to it. HTTP requests, if it could hear them or see them. Radius and Nmap, which it would go out and scan the switches and the devices for. DNS entries, what the devices are looking up for. SNMP queries to the switches and devices, traps being sent from the devices and switches, and then from Active Directory as well. We don't have that set up yet. That'll be here shortly. And then, of course, information from PXGrid. Really, the big one for us is going to be the radius side, right? We talked about IBNS and how it's going to send all of this device data via accounting to ICE so that ICE can munch on it and figure out what these devices are. With profiling, ICE is a lot like a general, so to speak, right? He's got all of these soldiers out in the field being our switches who are providing intel. He has kind of the database of, all right, based on all this information, I can piece it together and analyze it and come back and say, that is a Cisco phone. Now that I know that's a Cisco phone, this is how I'm going to handle it. So next, we're going to work with Active Directory here, the integration to it. That is underneath Administration and External Identity Sources. We can see here Active Directory. All I have to do is add my join point name. I will just call it NetTech. The Active Directory domain is networkingtechnician.net. It pops up and asks, do I want to join all of the nodes to Active Directory? We can say yes. Probably bad practice here, but I'm using my administrator account. Really, it's ICE joins a domain much like a PC. It actually physically joins the domain and creates computer accounts for the nodes. We'll go take a look at that here in a second. I'm not going to bother specifying what organizational unit I want to put these in, so we'll hit OK here. Typically very fast. We can see now that both of these nodes join the domain. If I jump back over to my domain controller and take a look at Active Directory computers here, we can see that ICE showed up, 2 accounts, 2 computers, 1 for each of my nodes. Next, we will want to go over to our groups. So here are groups that become available to us later on to use in policy. So right here, we obviously don't want to go in and, in a big Active Directory structure, add everything from Active Directory, right? There, in a normal environment, there would be a lot of groups listed here. We really only want to add what we're going to use, and obviously that's so that ICE doesn't have to sit and monitor those groups for changes and whatnot in the background from an overhead perspective. So for right now, I am going to add just domain users and domain computers. So domain computers, domain users, hit OK here, save. And for Active Directory right now, that pretty much does what we need. Now moving on to everyone's favorite topic of certificates. For EAP-TLS, obviously we need to have a server certificate here on ICE, as well as certificates on the endpoints. For PEEP, MS CHAP, obviously the clients only need to trust the server cert, and we pass username and password in that sense rather than certificate. So either way, I have to have certificates on ICE that clients are going to trust. So under administration again, I've got certificates. You can see here there are a bunch built in. These were self-generated by ICE. If we view one of them, it is indeed just a locally generated cert. So what we need to keep in mind here is that the clients need to trust the cert that we assign to our EAP authentication. If they don't, obviously they're going to get a warning. Windows will pop up. I believe the new terminology is, are you expecting to see this network here? It used to be pretty straightforward with, certificate not trusted type of stuff. But in any sense, this cert has to be something that those machines trust. Now, in a peer Active Directory environment where later on here we will deploy certificates from our CA to the devices, we can use a internal cert for this EAP authentication. However, if there is any need to authenticate devices that we don't have administrative control of, if we start to think of iPhones or kiosks or specific devices that may not give us the ability to push certs to them, really is what I'm after there. In that scenario, it may make sense to use an actual public cert for ISE and its EAP authentication. That way, most of the public cert providers are going to be trusted by default by these devices. We know it's a valid cert. They know it's a valid cert. It's, housed based on whomever the authority is, whether it's Komodo or user trust, etc. So in my environment, that is exactly what I'm going to do. The process would be pretty identical whether you were going to use an actual cert from your certificate authority or from a public cert. We would come down to certificate signing request. We would generate CSRs. I'm going to say it's for multi-use. You can specify that, hey, this is only going to be for EAP, etc. But in my case, knowing that I'm using a public cert, I may want to use that for a portal. A web portal, web redirect portal, in which case, it being a public cert becomes even more important so that those clients trust it. Think of BYOD and guest authentication for redirects on those portals. I'm going to check both of my boxes. I'm going to leave this common name as the variable here for the fully qualified domain of the ISE node itself, and we will put in IT NetTech 5 Iowa US. Now we can add sans to this as well and modify this cert or request however we want, right? If I wanted this to also be valid for a future ISE node, say ISE 3.2, I could put this in here, and in that scenario, this would get listed in the subject alternative name of the cert. But in the lab here, we don't need any of this, so we will just go ahead and hit generate. It generated them. I'm going to hit export. You can see it downloaded them here as csrs.zip. And in the background, I'm going to go out to my CA, public CA, and key these, get them fulfilled. And when I come back, now once I click on certificate signing request, we'll be able to click on them, bind the certificate that was generated, and choose what options we want to use that certificate for. So I got those signed. What we can see is in my downloads here, this was the csrs.zip that ISE downloaded. I extracted that, grabbed the data from here, took it out to my CA, gave them that, they signed it, and once I got all of that approved, I ended up with these two files here. So we'll extract them, one for each node. This gets into a lot of conversation. You can use wildcard certs. I could have done just one cert, from a public perspective, knowing that you're paying for those certs, I could have just done one cert with multiple SANs for these nodes. Here, I just happen to have the 2 certs out there not doing anything, so I'm doing separate certs on the public side. And if we get in here, we can see they gave me back 3 different files. One of those is a bundle that contains the cert and all of the intermediate root. One of those is just the cert in a SIR. I think if I look at the file extensions here, yeah, CRT, and then a P7B. So now we need to fill these on ICE. This is going to fail. I'm going to go ahead and do it just to show you. If I try to bind this cert, and use it for EAP, in my case, and hit submit, and yes, it's going to come back and say the path validation failed. So in order to import these certs, we first obviously need to tell ICE that it needs to trust their root cert. So anything in the chain, I obviously need to bring in here. So in here, if I open up this bundle, I'll just use Notepad, we can see in here there are 3 certificates. And this is essentially the chain, where this is the root, the highest in the hierarchy, and then these are subordinates to that. You can actually check this. If I was to create a new text document, open it up, just paste in this cert, save it, change this to CRT. When I open this up, I can see, okay, this is a AAA Certificate Services cert. If I was to do the same for the other ones, ultimately what I would see is that it would be down here and it would show that it's a subordinate of this AAA. So just for fun, let's go ahead and just bring this one in right now. If I do an import, this guy, I'm gonna just tell it to trust it for everything. And now in here, I should see right here my new cert. Now, was that enough? If I come back to my signing request, 01, bind certificate, choose it, grab this guy, whoops, tell it to use it for EAP. Nope. So in this case, obviously, I did that just to prove you need the whole chain, right? We have to trust everything up the chain from our certificate. So in this case, I am going to do an import, and I am just going to throw it right at this whole chain. Here, we're saying, hey, there's already a cert there. That was the original one I imported. So in some situations, it may be necessary to import a duplicate. You wish to replace it. In this case, sure, why not? So now I should have all 3 of these in here. So I've got my AAA, the Sectigo, and the user trust. Those were the 3 that were in that list. Now if I come back down here and I bind this cert, it's going to say there's already one there. Now, the one that's there is obviously the current cert that ICE generated. So the problem with replacing this right now And again, I did this just to show, if I go back to system certificates and I look at this cert, this default self-signed, which is what it's trying to replace because the host name matches, it's going to replace for EAP, admin, portal, and radius DTLS. If I replace this, it's of course going to cause all of the ISE services to restart and come back up. Now, I don't really have a way around that right now, knowing that this cert is destined for my EAP-TLS, for my EAP, and quite honestly, being that it's a public cert, it's not so bad to have it for admin and portal as well, right? The admin being the web interface here, we can see it says not secure. Even if I were to go to it by host name right now, it still would complain because I don't trust the root of this cert that is, the local ISE certificate authority or the built-in default. So no matter what I do here, even if I was to try to bind this without setting it up for anything, it matches an existing. They have the same subject. If you proceed, the existing certificate will be replaced and the new will be given the roles. So no matter what I do, even if I try not to use it, that's what's ultimately going to happen. If we look at the system certificates and we view this guy, it said both certificates have the same subject, and that of course referring to this data here. And I really can't get around that because that is the name of the node, this host node. So let's go ahead and get that finished. It is going to cause ISE to restart in this scenario. The system will now restart. You'll be logged out while the restart occurs. I'm going to go ahead and pause because this will of course take some time for services to restart. And one quick thing to show here, I went ahead and tried to log back in, and you can see ISE does give us some information saying, hey, the server's still starting, please wait. So we'll wait. Okay, we got the login page here, so I think we should be back in business. So if we now go look at our certificates, we can see that it moved EAP, admin, portal, all to our public cert. So in this instance, assuming obviously Windows trusts that certificate authority by default, if I go to ISE 3.2, and there we go. So now we can see here that the admin shows us this certificate, which is this function here. Obviously EAP is going to use it as well, and radius DTLS, not that we'll be using that in the lab. So the next one, again, same thing, only this time we need this one, and it says same thing. It's going to reboot because it's overwriting the cert that's there. In this case, because that node is not the primary admin node, it just reboots in the background. So what we'll notice here is if I try to go to it, it's going to give me an error. It is restarting in the background, so I'm going to pause, let that finish, and come back. Okay, we're back, and this came back up. So now if we look at it here, we can see again, this guy is now our public cert. Now, on a node that is not the primary admin node for ISE, we can log into it, but we'll see a different story on what we can do. We'll notice here we don't have anything other than administration. So because this isn't the primary admin node, we cannot configure any of our policies or do any of that work here. So we get some basic NTP info, deployment info. Here is where I would go if I wanted to make this the primary admin node. Right at this point, I could hit promote to primary and it would take over the primary admin node. We can do some upgrades, look at our certificates and our CSRs. So we don't really ever have a need to log into any of the other ISE nodes directly. Even upgrades and patches, when we do them on the primary node, it handles it for the rest of the nodes in the cluster. So the only other thing we need in this scenario is the cert from our certificate authority as a trusted cert. Now, if we were only doing PEEP MS CHAP, we'd be fine with the way that things are right now. However, when we go to EAP-TLS and our clients are trying to authenticate with a certificate, we obviously have to trust the certificate authority that they're sending at us. Those certificates are going to be given to them from RCA. So in this scenario, we have to go get that cert and trust it. So in here, if I go to 172.16.50.11, the domain controller, which is also the CA, in here, I'm going to say I want to download the CA certificate. And it just downloads it as certnews.sir. I'm going to just do an import. Go to my downloads, grab this guy. And again, I'm just clicking all of these. Obviously, you would only want to, from a security perspective, only check the boxes necessary here, and it's in. So now down here we can see this certificate is trusted. This trusted certificates gets replicated across all the nodes, unlike our actual system certificates, which are on a per node basis. When we add something here, all of the nodes get this, and this stays in sync. So that pretty much wraps up our certificate work for now.